Hi, hello, welcome to Knowledge Center. In my previous session, I have started DC machines concept from the textbook Mehta, wherein I have solved question number 1 to question number 10. In this session, I am going to continue with the question number 11 to question number 30. So let's begin with the question number 11. The armature of a DC machine is laminated in order to reduce dash. Okay, so the laminations of the armature core is done to reduce the eddy current loss. And we use silicon steel to reduce the hysteresis loss. Copper loss is totally depends upon the flow of current in that, and that is not depends upon the what kind of material used for an armature. Friction loss depends upon the mechanical part of it, that is rotation of a shaft and all. Okay, so option for this will be the first one, that is eddy current loss. Now let's move to the question number 12, that is the current in armature conductors of a DC machine is dash. So the question is bit tricky here. When student or whenever the viewer look into the question that DC machine, they feel that the current will also be a DC. But actually the in armature we are going to get AC output. Whereas when it comes out of the commutator segment, it will be converted into AC to DC. So the current in armature conductor will be a AC. Option 3 will be the answer for this question. The greatest eddy current loss occurs in the dash of a DC machine. So for this you need to recall my first session. So in the first session I had one question that what is the major part of a DC machine. So the major part of DC machine is armature, because in armature we are going to generate the voltage. So the major losses we are going to get in armature only. The major eddy current, the greatest eddy current loss occurs in the armature of a DC machine. Option 4 will be the answer for this given question. I hope you are understanding the concepts. If you feel that it is helpful, then just express that in a comment box and also like the video here. Now let's move for the next question. The brush voltage drop of a DC machine is about dash. See, the brush voltage will be very small amount. It will not be of 0.1 or a 10. It will be in the range of 2 volt. So the brush voltage drop in a machine will be of 2 volt. Option 3 will be the answer for the question. Carbon brushes are used in a DC machine because dash. See, carbon brushes are used so that the commutation will be of a smooth process. You will not have much spark in the commutation process. Means the carbon lubricates and polishes the commutator. That will be the best option for this. Okay, that is the right answer for this. First option will be the right answer. And here the contact resistance will increase. When the carbon is used, carbon will have very high resistance. Okay, that is one point you should understand here. So that it can be used for an best commutation process. So we will discuss about this in further questions also. For this question, option 1 will be the answer. The armature winding of a DC machine is dash winding. Okay, so there is a possibility of having a lap or a wave winding. So whatever it is, it should be of a closed circuit. So option 2 will be the answer here. Is open, closed, or partly opened, or none of the above. So it is closed circuit. Option 2 will be the answer for the question. Now the commutator pitch for a simplex lap winding is equal to dash. So for this, first you need to understand what is that commutator pitch. Okay, the commutator pitch is nothing but the distance between the two commutator segments, here 1 and 2, and this is lap winding. So commutator 1 and commutator 2, the distance between these two commutator segments wherein two ends of the same coil is connected. So this is end of one coil, same coil, and this is another end of that same coil. So both are connected in between these 1 and 2. So the difference is 1. The total commutator pitch for a lap winding will be 1, because it is in just between of one half of this and half of this. So the commutator pitch is going to be 1. So this is the commutator pitch. Whereas for wave winding it is going to be more than 1. But for lap winding the commutator pitch will be equal to 1. Option 3 will be the answer for this question. In a simplex wave winding, the number of parallel paths is equal to dash. So in a wave winding, whatever may be the number of poles, the parallel paths will be equal to 2. Option 2 will be the answer for this. Whereas in lap winding, I think you get next question is that as the number of parallel paths in a simplex lap winding is equal to dash. So in lap winding, the number of parallel paths will be equal to number of poles. So option 3 will be the answer for this. And here you should be very careful about the word, that is simplex lap winding. In a simplex lap winding, we will have it is equal to number of poles. If it is a duplex, then number of poles into 2, double. If it is triplex lap winding, then number of poles into 3. That's how it's going to change. So as per this question, option 3 will be the answer, because it is simplex lap winding. The number of parallel paths will be equal to number of poles. The relation among commutator pitch, front pitch and back pitch is, so here the commutator relation can be given as, commutator pitch relation can be given as algebraic difference of the back EMF and the front pitch, back pitch and the front pitch. That is option number 2 will be the answer for that. In a DC machine, the number of commutator segments is equal to dash. See, number of commutator segments will be equal to the number of coils. So for that, I will give an example here. I will go to the previous picture where we had that commutator segments. Look into this. Okay, this is a commutator pitch. Okay, and this commutator segments, we call this as a commutator segment. So this commutator segment will be equal to the number of coils. Here we have one coil, so we will get one commutator segment, half of this and half of this, so one commutator segment. So the commutator segments will be equal to the number of coils, not depends upon the conductors or not depends upon the poles. It is depends upon the number of coils. The nature of armature winding of a DC machine is decided by dash. Okay, nature in the sense whether it's a lap winding or a wave winding. So how to make that decision? By looking into the armature the winding. You look at this. I have both the winding here. Back EMF and back EMF. Here we have the same, almost same back EMF and back pitch, and the front pitch is also looks same, whereas the commutator pitch is totally different here. The commutator pitch for lap winding, simplex lap winding is 1, whereas the commutator pitch for wave winding is going to be more than that. So this commutator, if the commutator pitch is more than 1, then it is can be considered as a wave winding. So by just looking into the commutator pitch, we can make a decision whether it is a wave winding or a lap winding. So the option for this question is 2, that is commutator pitch. Now the high voltage DC machine uses dash winding. Okay, so wave winding is used for high voltage and low current. So note down this point here. Wave winding is used for a high voltage and a low current, whereas lap winding is used for a low voltage and a high current, reverse of it. So for this option 2 will be the answer, that is wave winding. In a lap winding, the number of brushes required is equal to dash. So the number of brushes will be equal to the number of poles. That will be the option here, because in lap winding number of parallel paths will be equal to number of poles and number of brushes are equal to number of parallel paths. So number of brushes will be equal to the number of poles of a machine in a lap winding. In a wave winding, the commutator pitch is approximately equal to, see here the word is important, approximately. So commutator pitch will be greater than 1 when you compare to the lap winding. So it will be almost twice the pole pitch. Almost twice the pole pitch. It's an approximate value, not the exact. It depends upon the given data again. So we can say it is almost twice the pole pitch of a machine. For a given number of poles, more than 2, and armature conductors, a lap winding will carry dash a wave winding. So question looks bit lengthy, but concept simple. If you know the concept, you can easily answer these kind of questions. The concept is, the current flowing in a lap winding, will it be more or less? That's the question here. For a given number of poles and armature conductors, a lap winding will carry dash a wave winding. Options are more current, less current, same current, and none of the above. As I already told you, lap winding is used for a high current and a low voltage. So lap winding will carry more current than a wave winding. That will be the option. Option number 1 will be the answer for this question. An 8-pole 250 volt wave wound generator has 400 conductors. If the generator is to be lap wound, the number of conductors required is dash. See, it's not just a problem here, they are just asking your logic here. If there is a machine with 8-pole 250 volt and 400 conductors and it is in wave wound, now I want to change that wave winding to lap winding. If I want to change it to lap winding, so how many number of conductors are required for that? That is the question. Okay. Now we need to know the relation of that lap conductors and the winding here. Okay. So for that I have written equation here. We have a basic equation, that is back EMF is equal to 5Z NP by 60 into A. Looking into this, if I write an equation for a Z, that is number of conductors, Z will be equal to 60A EB by P phi N. So here number of poles are 8 and parallel paths for wave winding. So if I write it in terms of wave winding, for wave winding Z will be equal to 60. I write that EB as it is, number of P phi N that as it is, whereas A will be equal to 2. because we know that parallel paths for a wave winding is 2. If I write the same expression for lap winding, that is going to be changed like this: Z is equal to 60 into 8. How I got 8? Because it is parallel path, and parallel path will be equal to number of poles, and remaining part is remains same. So here, by looking into this expression, we can say for lap winding the number of conductors are increased by 4 times, whereas in wave winding it was 2, now it has become 8. So 4 times it has been increased. So for wave winding, if the conductors are 400, then for the lap winding it should be increased by 4 times, that is 400 into 4, that is 1600. So option 4 will be the answer for this question. An 8 pole duplex lap winding will have dash parallel paths. Okay, so as I already told you, if it is a simplex lap winding, then the number of parallel paths will be equal to number of poles. Now it is duplex, so it should be double the time of poles. So 8 poles means twice of 8 is 16. So option 4 will be the answer for this question. 16 will be the answer. A triplex wave winding will have dash parallel paths. Again the same logic has to be applied. For wave winding, the parallel paths will be 2. But if it is triplex, it is thrice of that is 2 into 3. So option 1 will be the answer, that is 6. And let's have a last question for this session. That is, for a given DC generator, the generated voltage depends upon dash. As I already given the equation that EB is equal to 5Z NP by 60 into A, wherein other parts are going to be constant. The back EMF depends upon speed and flux. Option 3, both speed and flux, will be the answer for this given question. So if you feel it as an helpful video, then share it among your friends and also subscribe to my channel so that you can get the notifications of new videos. Thank you.